So in this video, we're going to start Unit 2, and we're going to look at, it's called Properties of Exponents. So you are going to get out the note sheet that I gave you in class called Section 10.1 and 10.2, Math 082. If you were not in class and don't have it, then I did post it as an announcement on Brightspace, and you can print it out. So we're going to look at some properties with exponents. So just to remember, an exponent is like x to the fourth. The exponent is to the fourth, and then x is called the base. So this is my base, this is my exponent, and we talked about it in our very first lesson, is that the exponent means that I'm multiplying x to the fourth times itself, x times x times x times x. That's what x to the fourth is. Okay, it's x multiplied by itself 4 times. Okay, so the first thing is, what is the difference between 3x and x cubed? So 3x just means 3 like times x, or 3 multiplied by x, where x cubed means, again, I'm multiplying x by itself 3 times. So they're very different. 3 times x is very different than x cubed, which is x times x times x. Okay? Because 3 times x really means x plus x plus x is what 3 times x. I'm adding it to itself 3 times. So we are going to do a bunch of stuff with exponents. And the first rule we're going to look at is called the product rule. So I'm going to start by like writing these all out, and then we're going to look for a shortcut to make our lives easier. So I showed the first one for all of these. So 2 squared means 2 times 2. And then I'm multiplying 2 to the fourth. And if I write out 2 to the fourth, I have 2 times 2 times 2 times 2. So like this part, again, is 2 squared. This part here is 2 to the fourth. And I can write it all out. Okay, so if I want to like simplify this, and I'm not multiplying it out, but I'm writing, what would this be just as 2 to an exponent? And so it would be, I have 2, if I count how many, I have 1, 2, 3, 4, 5, 6. And so this is really 2 to the 6. So we want to do this for like all of them. So like 3 to the fourth is 3 times 3 times 3 times 3. That's 3 to the fourth. And then I'm going to multiply by 3 to the fifth. And 3 to the fifth means I'm doing 3 times 3 times 3 times 3 times 3. So I need another 5 threes. And so if I count it, I have 1, 2, 3, 4, 5, 6, 7, 8, 9 threes. And so this is the same thing as 3 to the 9th power. So this one, if I do multiple, it's kind of the same idea. So I have 5 to the first, so that's just 5 times. Then I have 5 squared, which would be 5 times 5. And then I have times 5 to the fourth, which would be 5 times 5 times 5 times 5. Okay, so if I count how many 5s I have 1, 2, 3, 4, 5, 6, 7, and I have 5 to the 7th power. Okay, and I can do that with variables too. So x to the 9th means I'm going to have x multiplied by itself 9 times. 1, 2, 3, 4, 5, 6, 7, 8, 9. Here I'm going to have x to the 5th, 1, 2, 3, 4, 5. And then if I count these, you can pause and count them. But I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So I have x to the 14th power. Okay. And same thing here, x squared times x cubed. X squared is x times x. X cubed is x times x times x. If I count, I have 5 x's, so it's x to the 5th. Okay, and then this last one, I just have x, okay, which is really like x to the first if we don't write it, times x cubed, x times x times x, and then we have x to the 4th. Okay. So this is a very long process, especially if I have a high exponent. And so we want a shortcut. Like that's the whole point. I want a shortcut for this. So I want to say, okay, how could I get from this to just this without doing all of this work? So if you notice, okay, here I have exponent of 2 of 4, and that gives me 6. And here I have 4 and 5, and that gives me 9. And here I have 1, 2, 4, and that gives me 7. So you're trying to look at a pattern, like how do I get from here to here? And you may want to pause and think about it for a minute to see if you can figure it out. But after thinking about it, hopefully you realized is that if I take the base, the same, and I just add my exponents 2 plus 6, 4, I get 2 to the 6. And on this one, if I take it and I add 4 plus 5, then I get 3 to the 9th because I have 9 threes now when I multiply it out. Okay, this one I would have to add all three. 1 plus 2 plus 4. And then I get 5. 1 plus 2 is 3 plus 4 is 7. So this is called, again, that power rule. This one, 9 plus 5 is x to the 14th. That's what we got. This one, x is 2 plus 3, which again is x to the 5th. And then the last one, if we don't write anything, we again put an x on it. So this would be 1 plus 3, which is x to the 4th. So we want to come up with a general rule when we multiply two numbers with the same base. Okay? And so anytime we multiply two numbers with the same base, we add the exponent and keep the same base. And so it's kind of in a formula how we write it is if we have x to the a times x to the b, we get x to the a plus b. Okay, so the base has to be the same variable or the same number, but then we can add the exponents. And then the next part is why do we think it's the product rule? So if we think about what we learned in section 2.6 when we were translating statements, product means multiply. And so it is the product rule because we're multiplying two numbers with the same base. So we are doing a product when we're multiplying. And that's why it's called the product rule. Okay. So that's the first rule, and I'm going to make a different video for each rule to kind of keep them short.